Hey, good morning, guys. This is Ajay Sisodia. Today, I decided to, to make a video, a 2 minutes video, small videos on FEA, maybe on a 2 times or 3 times a week, or 1 times in a week. So, today's the topic is what are the method to solve any engineering problem. This is very important, question. You guys are engineers, right? So it may happen like, if any company come to you and asking for a solution for a particular problem, so you should know like what kind of solutions you have, what are the method you have to solve that problem. Again, it depends on a small problem or real life problem, or what kind of problem you are getting it from there. So there are three methods to solve any engineering problem. First one is the analytical method, second one is the numerical method, and the third one is the experimental method, right? So what is analytical method? Analytical method is a method which we already have studied in our engineering classes in our college, universities, right? So it's a 100% accurate method. Why it is 100% accurate method? Because it's a formula based, right? We know sigma equals to P by A, right? So you have a predefined formula, predefined cross-section area, so you can easily get the results 100% accurate. But there is a limitation for this method. What that limitation is? It is applicable for very small problem. What are those problems? Simply supported beam, right? Trusses, bar. So these are the simple problems, right? Like on a book, on a strength of material book, you have saw a lot of cantilever beam, simply supported beam, bar and all. So you have a predefined formula, you are getting all the inputs in a numerical, and you will solve the sigma and the del L, right? When it comes to the numerical method, now there is another method which is a very important method, and that's belong to the finite element analysis. So it's approximation, basically. It's an approx method, but you can deal with the real life problem. It's an approx method, and there are some assumptions. Why it is approx method? Because we have to take some assumptions. Assumptions may be in the form of, sometime maybe in the form of boundary conditions, maybe in the form of loading, or depends, So assumptions are required. Assumptions are maybe like in FEA or doing modelings and all. So you require the assumptions. So that's why it is not 100% accurate, but you can come very close to the 100% accurate results also. And it's applicable even if you have a physical model, if you have a real life model, right? So you can, with the numerical method, you can solve any real life problem, any real life model, any real life problem. That is the biggest advantage, and we used to, in FE basically, it's based on the numerical method. Then it's come to the third method, that's an experimental method. So this method you guys already know about it, right, in your engineering laboratory. So when you are in the first year, I think you might have seen that universal testing machine on your lab, correct? So I know that it doesn't work there in the college laboratory, but yes. So from there, there are a lot of gauges, a lot of kind of instrument, measuring instrument, where you can measure the actual stress, deformations, force, and everything you can actually measure. And but the thing is, like, you required a lot of setups there. You required a manpower to handle those problems, right? You required setups, you required money, and you required a time, basically. So experimental method, it's again a 100% accurate method, because you are experimentally measuring the thing based on the given loads and body conditions, based on the required data, right? So these are the three methods that to solve any engineering problems. I hope you guys will like it, and the next maybe in the next week, or maybe in the next video, we'll going to look to some other topics. Thank you.